So, turn on the board and let me know if it is visible for you all.
Hello, ma'am.
Hi, Abraham. Good afternoon.
Mhm. Good afternoon, ma'am. I have a question, ma'am. There was a blank page on the test on the maths paper. What was that for?
Um, what did you ask, Abraham? Can you repeat it once again?
Ma'am,
Ma'am, there was a blank page on the maths paper.
There was a blank page in the math paper. Yes, there was. I think while making the PDF, that blank page came there. Okay, so it's fine. Like doesn't matter. So what I wanted to discuss is
ma'am,
there
when will
was
the results come for the test?
today evening.
Today evening.
Yes, I checked half of two papers. I checked, two were still left. So today evening I'll be sharing the results. Okay, and
Ma'am,
yes, Edric.
ma'am, today are we doing test doubts?
Test doubts. There is one thing that I wanted to clarify. Okay, that was question 7. Question 7, third part. Okay, third part. There was error in the question. Okay, there was error in the question, so I'll be giving all of you bonus marks. Okay, 3 marks, bonus marks to all of you. All I'll be giving for that
Thank you,
question.
ma'am.
Okay, yes, because what happens, see, Edric, I took that question from the exercise, okay, at the end of the chapter. So, there was this question, it was written CI minus SI here, and here the value was 549. Okay, then there was your rate 20%, 20% it was given, okay, and time was given 9 months. 9 months was time was given and compounded quarterly it was given. Okay. So what I didn't read this part while giving you the question. CI minus SI. So 549 is the difference. Okay, this is not CI. In test I mistakenly gave you CI, this value. Okay. Here, this is the difference. Difference. And this question is of exercise 9.6. 9.6. Okay. It's from exercise 9.6. So, but the test was still 9.3 only. This test. So, I'll be giving you bonus marks for this question. Okay. Bonus marks for this question I'll be giving you. All right. And to see how to solve it, this formula I explained that when you're given the difference and you have to find out the principal, this formula we use. Difference equals to principal rate. This is compounded quarterly. So we do rate by 4 by 100 raised to the power 4n. Okay. So you place the values here. Difference, place the value 549 equals to principal rate is 20 by 4 divided by 100, and 9 months will be 9 by
Ma'am,
12.
could you
Yes,
move the screen a little bit because um, the bottom working of yours is being, yeah, thank you.
okay. So 20 by 4 by 100. So 9 months becomes 0.75. And we have to multiply it with 4. So 0.75 into 4, which becomes 3 raised to the power 3. Okay. So when you will solve like this, you will get your answer in this question. Okay. There was the error in the question. It was not 549 wasn't compound interest. It was a difference between compound interest and simple interest. Okay. This was the question. So this is your homework. Okay. Solve it in this way. Okay. You can solve it using this method and share with me. Okay, this is your homework. I hope this part is clear to you all.
I have a question, ma'am. Why is this
Yes, ma'am.
20 divided by 4 and not by 3?
Because in Anna, it's compounded quarterly, and in a year, how many quarters are there? 4 quarters are there, 3 months each, right? 4 quarters are there. January to March is one quarter, then April to June is another, then July to September is the third quarter, and October to December is the fourth quarter.
Okay.
Okay?
Thank you, ma'am. Ma'am, I have another question. When it's saying
Yes.
that the time was 2 years and it's compounded annually, then we won't reduce the rate, right, ma'am?
Yes, Anand. Yes, definitely. If it is saying compounded annually, then you don't have to divide by 4. And here also, it will just be raised to the power. You have to multiply it with anything, okay? In the case of annually. Okay? Like this we saw. So try this out, and bonus marks will be given for third question 7, third part. Okay. All right. So can you see who's has Sunil joined here? No. Okay. Sunil was having doubt in this part. Please check whose device is drawing on the screen. Please see. So now we are starting with a new chapter. Okay. We are starting with this is actually a previous chapter, and it's a backup. Okay. Its name is Introduction to Algebraic, yes, equations. Introduction to algebra. Okay. Let's do it. So, what is algebra? In
Ma'am,
algebra, yes,
ma'am, algebra is X, Y, Z.
yes. So in algebra, we use numbers with alphabets. Okay. In algebra, we use numbers plus alphabets. So alphabets, what kind of alphabets we use? We can use any alphabets like X, Y, Z, etc. Okay, and they are known as variables. Okay? These are known as variables. Okay, so two terms I'm going to use right now with you guys. Okay, we will learn
Ma'am,
about two terms. Yes,
ma'am, you wrote 3 instead of Z.
I need to get like that. So, two terms we are going to learn about. Okay. What are they? Constant. One is constant. And variable. Okay. So, suppose, let's take an example.
Ma'am, someone erased it.
Someone erased it. Please see who has erased it.
No.
Okay. So, please take care of it. Okay. Please don't erase it.
Ma'am,
Yes.
ma'am, I'll tell you the difference between arithmetic and algebra. Ma'am, arithmetic is only numbers and plus minus into division and all. Then algebras,
Mhm.
numbers and alphabets. And you can also use a plus minus into division, etc. Ma'am, wait. Ma'am, right.
Yes. Very good. That is correct.
Came back.
Arithmetic is only numbers, operations with only numbers, and algebra is operations with numbers and alphabets. That is variables. Okay. Now I was explaining. Please don't write on anything right now. Okay. I don't want anyone to write anything right on the board or in your copy right now. Okay. Listen to what I'm explaining first. See, what is constant? Let's take an example. Suppose, how many days are there in a week?
Ma'am, 7.
7 days. Okay. So,
In
does
5.
it change? Does it change?
Ma'am, no, ma'am.
Yes, it never changes. Okay, 7 days are there in a week and it is constant. Okay. How many months are there in a year?
12.
12. And does it ever changes?
No, ma'am.
No, it never changes. Okay. So those are constants. Okay, those are known as constants. Just 1 minute. Okay. So these are the numbers which have fixed value. Okay, they have fixed value. Example, 12 months in a year. Okay, that is a fixed value. And if I talk about variables, okay, variables are the ones which cannot be determined by a fixed number. Okay, constants are also fixed numbers. Fixed numbers, okay, numbers which have a fixed value. If I talk about variables, do you know what's the meaning of variable? Something
Ma'am,
that
variables, it keep changing.
yes, it keeps changing. That's what variable means, okay? Which cannot be determined by fixed numbers. Cannot.
Ma'am,
Yes.
ma'am, is pi a fixed number?
Pi is a fixed number. Value of pi is a fixed number. Okay.
Ma'am, but we
Value.
represent pi with a symbol, no, ma'am?
Value of pi is either I think it's
Ma'am, not 14/7. Ma'am, it's 22/7.
22 by 7. Yes. 22 by 7 or 3.14. Okay. This is the same value that we use. Okay. Please don't write on the screen.
Ma'am, even if you put view, ma'am, even if you put view only, there is laser. So when a person writes on the screen and they're continuously writing, the thing will stay. But as soon as they leave, the thing will go.
Please don't write on the screen, whoever is doing that. Can you lift it up? Can you check whose device is doing it?
No, ma'am, neither of us can check. Only you can check, ma'am. It's because it's only for us to see.
Okay. Okay. So the values for your question, the values that we use in pi, those two values are fixed, okay? But the ultimate answer differs based on the numbers that are the other numbers, the constants that the question is having. Okay, the constants that the question is having. Based on that, your answer differs. Example, for constant and variable that I was explaining.
Ma'am, so variables don't have any fixed value.
Yes, variables don't have any fixed value. Okay? Suppose let's take an equation 5x plus 3y plus 8. Okay. So in this, x and y are variables. Okay. X and y are known as variables. Okay, the single number that I'm having is known as constant. Okay, this is known as constant. And a number which is written with the variable is known as coefficient. Okay, 5 and 3.
Ma'am, so you're saying that variables are not constant, right?
Ma'am,
What is not constant? Yes.
ma'am, see, the coefficient of x is 5. The coefficient of y is 3.
Yes, that's right. Okay. So the numbers which are written with variable, okay, those will be called the coefficient of your variable. Okay, like this, 5 is the coefficient of x and 3 is of y. The number which is written as single number, only number, no variable is known as constant.
Ma'am,
And
so what are variables? You didn't write down the meaning. I wasn't able to follow.
I wrote the meaning before. It got erased, which
Ma'am.
cannot be determined by. Yes.
Ma'am, see, ma'am, 5x is written as 5 into x, not 5 plus x.
Yes, that's right.
Ma'am, could you drag the screen a little down? We can't see your writing.
Okay. Which cannot be determined by fixed numbers and represented by alphabets.
Ma'am, please drag the screen a little down. We can't see the writing.
Now can you see?
No, ma'am, you have to take your cursor and drag the screen. The thing you've written in red, we can't see. At least I can't see.
And I have the screen.
Can the rest of you all see?
Yes, ma'am, I can see.
And I tried from your side. Try scrolling up or to the side from your device.
The option is in there, ma'am. You, I think, disabled it. I
No,
had
none of the
to
op-
decrease the size of my screen to see it. I can see it.
okay.
and now the option is there. I'm able to do it very easily.
Where is it, Abraham?
I'm just moving the screen with my finger.
Are you using a phone? Okay, yeah, now it's there.
No, a
Now it's there. Now
tablet.
it's there.
Okay. So I hope the difference between constant, variable, and coefficient is clear.
Yes, ma'am.
Okay. So have you all written this equation?
Yes, ma'am.
Okay. First one. One more we will see. Okay. 2x plus 4y equals to 9. Now in this equation, what are my variables?
Ma'am, x and y.
Yes. X and y are my variables. Okay. What's my constant?
Ma'am, 9.
Yes. 9 is my constant. And what are my coefficients?
Ma'am, 2 and 4.
Yes. 2 and 4 are my coefficients. Okay. Now, we also use variables x and y and any other variables to represent the missing value of something. Okay. To represent an unknown value that we don't know yet. Okay. That we don't know. So for that also, to represent that, we also use variables. Okay. How? I'm clearing this page. Suppose
Ma'am,
I
I
have,
have a question. Ma'am, I have a question.
yes, Abraham.
And when we're removing variables or like, so ma'am, why are x and y always like you, and then like there's a most number of like x and y are used most frequently.
Why X and Y are used most frequently? Because they are the most common variables. Okay, most common variables. But like other variables are also used, like A, B, and C are also used. Okay,
N
and you
also is
can use
used a lot. N.
N. Yes, N is also used a lot. Okay, so X, Y, Z, and they are most common.
Ma'am,
But yes,
ma'am, N is used for the time in simple interest and compound interest.
N is used for the time in simple interest and compound interest. That's right. Okay, so I have total X topics. If you look at this example, I have total X number of topics. I don't know how many. Okay, so I gave you, I gave you all one each. So how many I gave you all?
One each, ma'am. So you're
Three.
so ma'am, you have three topics.
Three topics I gave you. Okay, now I'm left with how many topics? I'm left with 11 topics.
Mom, you had 14 toffees.
That's right. Okay. Now we will see how do we write this statement in equation form. Okay. How do we write it in equation? So total topics, I don't know how many, so I will assume that it's X. Okay. I gave you out of my total, I gave you all three. That is minus three.
Minus
Yes, equals to
11.
now I'm left with 11. So 11. Okay, so this is the equation. That's how you write a statement in equation form. That is what we are going to learn next. Okay, that how to express statement or a
Ma'am,
situation as equation. Yes,
ma'am, and these equations are called linear equations in one variable because there's only one variable called x.
that's right. So these are known as linear equations in one variable. Okay. This equation is called linear equation and in one variable because only one type of variable is there. Okay. Suppose if I had 2x plus 3y. So this is what equals to 16. So I'm having two types of variables, x type and y type. So this is linear equation in two variables. Okay. So yes. Coming back, x minus 3 equals to 11. So we know that numbers on one side and variable on one side. So we will take minus 3 on this side. X equals to 11. Now when we are transporting a number from one side to the other, its sign changes. So minus sign on the left side becomes plus
Plus.
sign on the right side.
Ma'am,
Equal to 14.
ma'am,
Yes.
ma'am, plus will become minus, minus will become plus, into will become divide, divide will become into.
Yes, that's right. Okay. So this is how we can solve them. All right. Now we will do some equations. I will tell you some statements and you will give me their equation. Okay.
Ma'am, I've learned this before, ma'am.
You've learned this before. Okay. That's great. Raman's age is double the age of his younger sister. Okay. His age is double the age of his younger sister. Okay. Now, let's assume that the age of his younger sister is X. Okay. Let age of younger sister X. Okay. So his age is double, means two times the age of his younger sister. Okay. So Raman's age will be, I can multiply X with 2, right? I can multiply X with 2. So it will be 2 into X. Raman's age is 2 into X. Now, when we are multiplying a number and a variable, like I always explain, we just write them together like this. Okay, 2x it
Ma'am,
becomes. Yes,
ma'am, that's why I told you that 2x is 2 into x, not 2 plus x.
yes, that's right. Okay, 2 into x it is. Next, one we will try. 1/4 the length.
Ma'am, Abraham wrote x into 2.
X into 2 is also correct. Okay, x into 2 is also correct.
Ma'am,
Yes.
ma'am, I was gonna say, I was thinking of 2x is because x into 2, but I didn't write, ma'am. I didn't write
No
anything on the
problem.
screen.
Can you clear the laser? Anyone?
Ma'am, no, you can't clear the eraser. The laser.
You've heard this property, A plus B equals to B plus C,
Many
and
times, ma'am.
Yes, ma'am,
A
I heard about.
into B equals to B into A. So
Yes.
this is applicable. Yes. So this is applicable in algebra too. Okay.
Ma'am, same like
Um,
x plus y equal to y plus x into y equal to y into x.
um, Hello. Yes. Actually, now tell me.
Ma'am, same like, ma'am, in algebra it's like x plus y equal to y plus x and x into y equal to y into x.
Yes, that's right. Okay. So even if you do, like in the previous question I was telling you, even if, please don't write on the screen, even if you do x into 2 or 2 into x, both are the one and the same thing. Okay, same thing. All right. So next we will try out. Let the length, 1/4 the length of a rod. rod. Okay, 1/4 the length of a rod. So let the length of rod. This is the total length. Be x. Okay. Suppose this is my rod. Okay. And its total length is x. Now 4 parts, and I have to represent this part, 1/4 part of the rod. Okay, so 1/4 length of the rod will be how much?
X by 4.
One by 4 into x. That is x by 4. Okay, or 1 by 4x. Both are correct. Okay, this is how you represent a statement or a situation as an equation. Okay, as a linear equation. Okay. One more we will see. Pair of a child is part half of the pair of the distance.
Mom, what?
What is pair?
Then FARE. What is fair?
Pair means the price of the ticket. The price of the ticket that you have to pay. Okay, the price that you have to pay to travel. Yes, to travel between two stations.
Ma'am, what is this you have written on top? Part half of the what?
Part half of the fare of the distance
Fair.
between two stations. Part half of the fare, FARE. Okay. So now what happens? This is my station one, and here is my. Now this distance between station one and station two, okay, is let's take it as x. Okay, so let pair two stations be x. Let pair between two stations be x. Okay, now fare of the child is half of the fare between the two stations. Okay, means if the total is x, fare for the child will be half of that x. Okay, fare
Ma'am, fare of child
for
will be x by 2.
yes, very good. Equals to 1 by 2 into x. Okay, that is x by 2 or 1 by 2x. Okay, means half of x. Half of x is x by 2. Okay. So I hope this part is clear.
Yes,
Yes, ma'am.
Okay. All right. So we will stop here, and tomorrow we will see how do we operate when we are doing addition, subtraction, multiplication, and division with variables. Okay, that we will understand.
Ma'am,
Yes.
ma'am, 1 minute, ma'am.
Sorry.
Ma'am,
Yes, Andrew.
ma'am, keep the classes in the morning, ma'am, please.
Why? What happened?
Ma'am, 3 o'clock is so late, ma'am.
3 o'clock is late.
sorry,
Um,
I have school in the morning, so I can't attend in the mornings.
okay. So this time is like convenient for everyone. Andrew. That is why we kept this time. And I will see, like, once my college starts, I'll see if I can continue with this time or might have to shift it. But until then, 3 is the time. Okay.
Why, ma'am? Why would you have to shift this time?
Because I'll be starting with my colleges
With
soon.
your college?
Yes.
Oh,
Okay. Yeah. So, like,
I thought you had
graduation is
graduated,
done.
ma'am.
My graduation is done. It's done. I'll be starting with a 2-year program, okay?
Oh,
Engineering program known as BEd.
okay.
Yeah. So that I'll be having colleges. Might have to shift it, but whatever it will be, I'll let you know. Right now it's at 3 only. Okay. Yeah.
Okay,
So
ma'am.
that's all for today. Okay, that's all for today. See you, Edric, tomorrow.
Bye, ma'am.
Bye. Okay, so 4 minutes break. And I need Abraham till 3:50, and then we'll meet for the science class.
Yes, ma'am. Thank you.
Okay. Okay, let's continue. Let's divide by 1. Can I have your videos on, please? Okay, if you have it, hope you are there too. Today we were supposed to start a new chapter. Hope the screen is visible. Okay, so today we will start with the chapter heat. Okay, what is heat? It's a type of energy which is related to the motion of the molecules of a substance. Okay, like if we observe in our daily lives, we experience heat, okay, every day, I think. Just when we are near a flame, sometimes in a summer day, you know, on a hot summer day, when we are cooking or when we are taking a bath with hot water. Yes, so we all experience heat, having and cold also every day. Having less or more heat causes us to feel cold and heat. When heat flows out of our body, we feel cold. If heat flows into our body from the outer environment, then we feel hot. Okay, you can experience that in the change of seasons. When the heat flows out of our body, we feel cold. But when the heat flows into our body, we feel hot. Okay, and heat is basically a type of energy. Okay, and it's related to motion of the molecules of something, okay, of a particular substance. So a physical quantity which determines the direction of flow of heat is called its temperature. Okay, means that it is a quantity, okay, which determines um, the flow of heat. Okay? What exactly, like how exactly this is determined? Okay, we know that we when we say that the temperature is high, means that more heat is there. When we say temperature is dropping or lesser temperature, means less heat is there. This we know. 1 second. Yes, guys. So we were talking about heat. So this we all know. Now, what is the flow of heat? Like how the flow of heat is related to temperature. Okay, like how is that related? We will see. Okay. Suppose there is a substance. Let's take um the sun. Okay. For example. Now we know that this is one of the hottest things. Okay. the sun has the hottest temperature. Okay, if we compare it to other things, this we know. So why, like, what happens that it has this very hot temperature? Because it has molecules, and in the sun, the movement of those molecules is very fast. Okay, due to that, there is this high temperature. Okay, due to the fast moving molecules that we have to keep in mind. Okay, suppose there is this is my flame. Okay, and on that I have a vessel. Okay, and I'm boiling something. Okay, and I'm boiling something which will be hot. Okay, its temperature will be high because the movement of molecules is high. Okay, fast movement of molecules is there. Okay, so when the molecules move fast, they produce more energy. Okay, when the molecules move fast moving molecules produce more energy, and this energy causes more heat. Okay, this energy that's produced with fast moving molecules, it causes more heat. Okay, more energy exists in the form of heat. Heat always flows from a body at higher temperature to a body at lower temperature. Therefore, during the summer, when the temperature of environment is more than our body, we feel hot. And in winter, the temperature of outside is less than the temperature of our body, we feel cold. Okay, try to understand this. Heat always flows from a body at higher temperature to a body at lower temperature. Okay, this is a body means something high temperature, and this is something, okay, here lower temperature. Okay, so heat flows from the body a high temperature to a lower temperature one. Okay. Now that is why in summers, make it here. This is us, okay, and this is the environment. Okay, this is the environment. So in summers, what happens? The temperature of environment is more. Temperature of environment is more than the temperature of our body. Okay, this is why we feel hot. Okay, because if when like here I explain in this part that how heat moves from a body with higher temperature to a body of lower temperature. Heat is moving in this direction. Okay. And here our body has lower temperature and the environment has higher temperature. So heat will move in what direction? In this direction. Heat will move. So because of this, we feel hot in summers. Okay. Because of this, we feel hot in summers. Okay. Because heat is moving from a higher temperature, that is from the environment, towards our body. Because our body has lesser temperature than the temperature of the environment. Okay, so that's where the movement of heat is taking place. The molecules of heat is taking place and producing more energy. Okay, so that's why we feel hotter in summers. Now, what happens in winters? Let's see. Temperature of outside is less than the temperature of our body. Now, let's remove the sun and let's make a moon here. Okay, this is winter. So the temperature of outside environment drops. Okay, temperature decreases, and here temperature increases. Now heat is traveling outside our body. Okay. Now what is the higher temperature point? This is the higher temperature point. Us. Okay. Now heat is traveling outside our body like this, in this direction. Heat is traveling. So we will feel cold. We will feel cold. Okay. Because heat is traveling away from our body towards where the temperature is dropping. Okay, so we will feel cold. This is what it has explained you. So I hope this part is clear. Any doubt? Do you want me to explain again
No.
anything? Okay. Abraham, any doubt?
No, ma'am.
Okay. All right. So we will move forward now. Effect of heat as an energy. Heat is a form of energy which is associated with the motion of the molecule of a substance. Okay. You might have seen that when water is boiled in a kettle covered with a lid, then its lid moves up frequently due to the pressure of steam. Obviously, steam is formed due to the heat which raises the lid up. Okay, so this we know that heat is a form of energy.
Ma'am,
Yes.
ma'am, no, like, ma'am, it will move up and down like the certain type of pots, ma'am, that there are that when there enough steam collected, then the nozzle moves up and lets all the steam.
Yes, Abraham. Yes, that's right. Okay. So, steam is formed due to the heat, which raises the lid up. Our clothes dry up in the sun due to heat. We obtain salt from seawater with the help of heat. Okay, these are how heat is essential to us. Okay, heat, as it has the capacity of doing work, is a form of energy. Okay, it is a form of energy. If you observe your surroundings carefully, you will find that many other types of energy are transformed into heat. Burning candles causes chemical energy to change into heat. The electric energy in electric furnace is converted into heat. In an electric heater, electric energy is also changed into heat. Okay. So, like electric energy is also changed into heat. When electricity flows, it produces heat. This we know, right? Then candle burns. How does it burn? Due to a chemical reaction. But what it produces? It produces heat. Okay, so those are other reactions, okay, other types of energies which produce heat. All right. Then what are the effects of heat? The higher the speed of the molecules of a substance, the higher its temperature. And by providing heat, the speed of its molecules increase. Okay. This is the speed of molecules. Okay. Speed, higher the speed, higher will be its temperature. Okay. Higher will be its temperature. Okay. By providing heat. When heat is provided, the speed of the molecule increases, which gives rise to its temperature of a particular substance. Okay. When any object is heated, one or more one or more of the following effects may appear. These are the effects, okay, of heating. Change in size. Metals like iron, mercury, etc. expand on heating. If that is change in size takes place, rise in temperature. When a body is heated, it becomes hot. Okay, that's rise in temperature takes place. I just explained. Then change of state also happens. Something solid changes to liquid and gases. Okay, like if you heat up, for example, ice cream. Okay, frozen ice cream. If you heat it, it will completely melt. Okay, it will completely melt and become in liquid state. Okay, so when you heat something, it solid substance, it changes to liquid and then to gas also, it evaporates. Okay. Where water in liquid state changes to solid and gaseous state. Okay. Liquid water forms ice, that is the solid state. If you heat ice, if you keep it at room temperature, it will again turn into liquid state. If you heat that liquid, it will evaporate and turn into gaseous state. Okay. Then change in physical and chemical properties of a substance. Iron, when heated, becomes red hot. Okay. Change in physical property, that is its color. Okay. Chemical properties also change takes place. Then damage to living cells, etc. If the leaf is lying in a sun, then it becomes dry. If the person remains in the sun for a long time, then the color becomes black because their body has a chemical, okay, which reacts with the sunlight, causes the skin color to darken. Okay, so that is when our skin is comes into contact with the sun rays for a long time, more amount of that chemical is produced in us. Okay, which affects, which causes tan, etc. Okay, that is the skin. So, measurement, that is all the effects of heat, okay, on various substances. Like what um, happens to something when we heat it, okay. So, one of it or more than one, it can change size, okay. It can be heated up, temperature can rise, it can change state, it can change its physical property or chemical property. And living things are also damaged if they're exposed to sunlight for a long time period or too much of sunlight. Okay, very strong sunlight, if they're exposed to, they die. Okay, then measurement of temperature. Measurement of hotness or coolness of a body is known as its temperature. Generally, we use our sense of touch to decide whether an object is hot or cool. But we can guess the temperature of an object correctly by touching it. Let's perform an experiment. This is an experiment. Okay, you can try it. Like putting a hand in ice water, hot water, normal water. Okay. So we can measure temperature with our sense, that is by touching it. Okay, but not exactly how. Uh, you cannot measure the exact temperature, this degree. Okay, you cannot say by just touching it. Okay, you need a proper device to get the exact measurement of the temperature. Right. So, thermometer is the device with which temperature is measured. Temperature of our body is measured. Thermometer that measures our body temperature is called the clinical thermometer. Hold the clinical thermometer in your hand and observe it carefully. you will find that a clinical thermometer consists of a long, narrow, uniform glass tube. Okay, this is a clinical thermometer. It has a bulb at one end. This bulb contains mercury. Outside the bulb, a small shining thread of mercury can be seen. You can see a kink near the bulb. This kink prevents mercury level from falling on its own when thermometer is taken out of mouth, and we can read the thermometer easily. Okay. So this is the scale on the thermometer that gives you the temperature. Okay. You have the kink present in it. You have the mercury. Okay, that rises up. That rises up. Okay, to show our temperature. The scale we use is a Celsius scale indicated by degree C. Okay, Celsius scale is used, and we indicate it using degree C. Okay, it reads temperature from 35 degrees C to 42 degrees C only. In a thermometer, another scale is also used to measure temperature, which is known as Fahrenheit scale. Okay, F, Fahrenheit scale. In Fahrenheit scale, thermometer reads from 94 degree Fahrenheit to 108 degree Fahrenheit only. Normal temperature of a healthy person is 37 degrees Celsius or 98.6 degree Fahrenheit. Okay, this is the same thing. In Celsius, it is less, and in Fahrenheit, it's more. Okay, 37 degrees C or 98.6 degree F for a normal person, normal healthy person. Okay, then it talks about reading a clinical thermometer. Before the use of thermometer, we have to wash it properly. Okay, and they suggest to wash it using an antiseptic solution. Okay, not just water, but to use some solutions are there to wash your medical equipment, to wash such equipments. Okay, so you can wash it using your antiseptic solution and hold it firmly. Give it a few jerks, means you give it a few shake, small shake you do. It will bring the level of mercury down. Okay, it will bring the level of mercury. It's a small ball-like thing down. Ensure that it falls below 35 degrees C. We have to see that it falls below this level. Now place the bulb of the thermometer under the tongue. Okay, bulb means this point, this part. Okay, under the tongue, or people do it in the armpit also. They place it the thermometer in the armpit also to check the temperature of the body. Okay, after 1 minute, take the thermometer out and note the position of mercury on the scale. Okay, the ball will move up. Okay, small silver ball is there. Okay, it will move up slowly. Okay, and it will rest on some point. Suppose here, will rest on some point. Okay, and that will tell you what the temperature is. Suppose this is 39 degrees C if it's resting here. So you will know that. And what is the normal? 37 to 30, 98. 37 or 98 degree, 98.6 degree F. So 39 degrees C means slight fever. Okay. Slight fever. Okay. So take the thermometer out and note the position of the mercury on the scale. This is your body temperature. Okay. That's how we know that what is the temperature. Then we also have laboratory thermometer. This is used to measure the temperature of other objects. Okay? There are other thermometers to measure the temperature of other things. There are different types of thermometers used. One of it is laboratory thermometer. Laboratory thermometer consists of a long, narrow glass tube. Okay, this is the glass tube. The lower end of this tube is like a bulb. This tube contains mercury or alcohol. Its upper end is sealed. This is the upper end. Okay, this is sealed, and this is the bulb part. Okay, and the glass tube is kept in ice cubes. The point in the tube where mercury becomes steady after getting cooled is marked as 0 degree. Now the tube is kept in the steam of boiling water. The mercury starts to expand inside the tube. The point in the tube where mercury becomes steady is marked as 100 degrees Celsius. The inventing space between 2 points is divided into 100 equal parts. Okay, this is the 100 equal parts which is divided. Okay. Thus, the measure of each small division is 1 degree C. Generally, the range of this thermometer is minus 10 degrees Celsius to 110 degrees Celsius. Okay, this is its range. Minus 10 degrees C to 110 degrees C. Okay, it measures very high temperatures. It can measure. Okay, and very low temperatures too. All right. Precautions we have. It should be kept upright while using. The bulb should be surrounded from all sides by the substance of which the temperature is to be measured. Okay, upright means like this. Okay, in a standing position. Then suppose this is my bulb. Can you see the tip of the pen? This is my bulb. So it has to be completely immersed in the thing which you are measuring. Okay? Whose temperature you are measuring. The front part of the thermometer has to be immersed in it completely. And the bulb should not touch the walls of the container. Okay? It should not touch the walls, okay, the outer part of the container. Right? So these are the precautions that should be taken. Okay. Then we have index questions 10.1. Currently on homework. Okay. Define heat. Do the MCQs and then finish up the diagram of clinical thermometer. Okay. Propagation of heat we will study tomorrow. Okay, propagation of heat we will study in the next class. Okay. All right, so I hope the preparation of the science test is going well. That's this Friday, the mega test.
Ma'am, so how will the test be?
How will the test be?
I mean, like, how will you combine the two chapters together?
How have I combined the chapters together? Um, from the fourth chapter, I have not like no questions are repeated. Like the questions that I gave in the previous test. Okay, I have not repeated them. Okay, but I have covered from the topics which are new. Okay, like some topics which I haven't asked in the previous test from that chapter. Those I have covered. Okay, and same thing for the diagrams. Okay, no diagram is coming back in the previous test, but new diagrams will be there. Okay, of the fifth chapter. So prepare the fifth chapter well and revise the fourth chapter too. Okay, I need you all to revise the fourth chapter once, but prepare the fifth chapter well. Okay. Prepare the diagrams well. The paper is more subjective. Okay. It's very less subjective this time and more subjective. All right. So prepare well. And Friday it is. Okay. What diagrams are important? What diagrams you have to prepare? I will post in the group today. Okay, of the fifth chapter. Fourth chapter, I'm on. Yes, fifth chapter diagrams are put in the group today so you guys can see and prepare. Okay, so we'll continue this chapter from propagation of heat tomorrow. See you all in tomorrow's class. Bye.
Bye, ma'am.
Bye,
Thank
ma'am.
you.
Bye, Naya.
Bye, ma'am.
Bye. Bye.